Right, architectures. That basically just means the overall structure or blueprint of the network. How many layers, what types of layers, how are they connected?
And different blueprints work better for different jobs.
Absolutely. It's not one size fits all. For instance, if you're working with images.
You mentioned CNNs.
Exactly. Convolutional neural networks, they use special convolutional layers that are brilliant at processing grid-like, data-like images. They learn to detect features, edges, textures, patterns in a hierarchical way.
Hierarchical.
Yeah, like early layers might detect simple edges, later layers combine those into textures or simple shapes, and even later layers combine those into parts of objects or whole objects.
Cool. So they're specialized for spatial information.
Very much so. CNNs usually also have pooling layers that downsample or shrink the representation, making it more manageable and robust. Then often, after several convolutional and pooling layers, the results feed into standard, fully connected layers for the final classification or prediction.
Okay, CNNs for images. What else? You mentioned ResNets?
Ah, residual networks. They were a major breakthrough for training really deep networks. Hundreds, even thousands of layers deep.
How don't gradients struggle in deep networks?
Yeah.
Vanishing gradients?
That's exactly the problem they address. ResNets use skip connections or residual connections. Imagine a block of layers. The skip connection takes the input to that block and adds it directly to the output of the block further down the network.
So it creates shortcut.
Sort of. It allows the gradient information to flow more easily back through the layers during backpropagation. It gives the network the option to easily just learn an identity mapping, basically passing the information through unchanged, which helps prevent performance from degrading as you add more layers. It combats that vanishing gradient problem.
Clever. CNNs for
Yeah.
space, ResNets for depth. Any others worth mentioning briefly?
Well, for sequential data like text or speech or time series, you often see recurrent neural networks, RNNs. They have connections that loop back, giving them a kind of memory for sequences.
Makes sense for sequences.
And then there are transformers, which have become hugely dominant, especially in natural language processing. They use a mechanism called attention to weigh the importance of different parts of the input sequence. They're incredibly powerful and are even being applied to vision now, too.
Wow. Okay, so lots of specialized designs built on the same core ideas.
That's